Now see this problem. Here a linear network is given and this is resistance R and this is current I through this resistance R. Now when resistance R is equals to 0, then current I is equals to 3 ampere, and when resistance R is 2 ohm, then current I is 1.5 ampere. So we have to find the current I when resistance R is 1 ohm. So to solve this problem, we use the concept of Thevenin's theorem. This network can be represented by a voltage source connected in series with a resistance. This is RTH, and suppose this is voltage VTH. Okay. Now this is connected through this resistance R and current through this resistance is I. Okay, this linear network is represented by a voltage source in series with resistance as per Thevenin's theorem. Now we can write VTH is equals to IRTH plus IR. Okay. Now when R is equals to 0, it means it is equals to 0, and then current I is 3 ampere. So we can write VTH is equals to 3 RTH. This is first. And when resistance is 2 ohm, it means this R is 2 ohm, then current is 1.5. So we can write 1.5 RTH plus this is 2 ohm, R is 2 ohm and I is 1.5, so we can write 3. Okay, now from this, if we replace this by 3 RTH, VTH by 3 RTH using first, then we can write 3 RTH is equals to 1.5 RTH plus 3. So simply we get RTH is equals to 2 ohm. So RTH is 2 ohm. Now what is VTH? VTH is equals to 3 RTH and RTH is 2 ohm. That's why we get VTH is equals to 6 volt. So after getting VTH and RTH, now we can find the current I when resistance R is 1 ohm. So in this equation, if we put VTH is equals to 6, okay, here we are using this equation. If VTH is equals to 6 and we have to find current I, that is RTH is equals to, what is RTH? RTH is this 2 ohm. So 2 plus, and what is R? Here R is 1 ohm. So now it gives I is equals to 6 by 3, that is equals to 2 ampere. So answer is 2 ampere. Now see this question. In this question, this circuit is given and we have to find Thevenin voltage across terminal AB. In this circuit, these two dependent sources are given. This dependent source depends upon the value of current in this loop, and this voltage source depends upon the voltage across this 4 Henry inductance. See how we can solve this. To find the Thevenin voltage, we open circuit the terminal AB. So when we open circuit the terminal AB, now we have to find the voltage across this terminal AB. So once we open this, then this I2 becomes 0. When I2 becomes 0, then this J40 I2 also becomes 0. 0 means it acts as short circuit. When it acts as short circuit, now we can apply KVL in this loop. Suppose here current is I. So we can write KVL equation as 100 angle 53.1 is equals to I into 3 plus J4. So we get I is equals to 100 angle 53.1 by 3 plus J4. Okay, when we solve this, we get 100 angle 53.1 by 3 square plus 4 square under root angle tan inverse 4 by 3. That is equals, so we get I is equals to 100 by 339 100 by 5 angle 53.1 by angle 53.1. When we take this angle in numerator, then 53.1 minus 53.5.1 becomes 0. So we get simply current I is equals to 20 angle 0. Now we have to find the VTH, and VTH is equals to the voltage across this inductor. So VTH is equals to VTH is equals to, as this loop is open, so this VTH is simply equals to 10 VL1 because current in this loop is 0. So VTH is equals to 10 VL1. Now what is VL1? VL1 is the voltage drop across this J4. So we can write 10 into J4. What is voltage drop across J4? That is J4 into I. J4 into I. And what is I? I is equals to 20 angle 0. So equals to 10 into 20 into 4J. So we get 800 J, or J is equivalent to 1 angle 90 degree. So, or it is equals to 800 angle 90 degree. So VTH is equals to 800 angle 90 degrees answer. Now see this question. In this question, this network is given and it is purely resistive. This is source voltage Vs, this is resistance R, and this is voltage V. Here it is given that when this resistance R is infinity, then voltage V is equals to 5 volt. Okay, this V is equals to 5 volt. When resistance is 0, then current through this resistor is equals to 2.5 ampere, and when resistance is equals to 3 ohm, then we have to find what is the voltage across this resistance. So this is simple question of Thevenin and Norton equivalent. When this resistance is infinite, okay, it means it acts as open circuit. In that case, voltage through this terminal is simply equals to Thevenin voltage. It means here VTH is given as 5 volt. Okay. And when this R is 0, it means when this resistance is shorted, in that case current through this resistance is 2.5 ampere. It means here INSC is given as, Norton current is given as 2.5 ampere. So what is RTH? It is simply equals to VTH by IN. So it is equals to 5 by 2.5, that is equals to 2 ohm. Okay, now when R is 3 ohm, in that case we have to find voltage drop across this resistor. So this circuit can be represented as VTH connected in series with RTH, and this connected with in series with this R. So we write this circuit equivalent to VTH in series with RTH. Here VTH is 5 volt and IN is 2.5, RTH is 2 ohm. So suppose current in this loop is I. So we can write equation as VTH is equals to I into RTH plus R. here RTH what we have calculated is equals to 2 ohm. So 2 plus, and what is resistance R? That is equals to 3 ohm, and VTH is equals to 5 volt. We get I is equals to 5 by 5. That is I we get is equals to 1 ampere. Okay. Now what is drop across this resistance? That V is equals to IR. I have calculated, that is equals to 1 ampere. R is 3 ohm. So that's why it is equals to 3 volt. So answer is this 3 volt. Now see this question that has been asked in ES 2009. Here this is voltage source V1, this is current source alpha I, and here in this question we have to find Norton current and Thevenin resistance across terminal AB. Okay, so this is dependent current source which depends on the current I in this circuit. So to solve this question, first we will calculate the value of RTH. Okay, now what is RTH? To calculate the RTH we have to keep the dependent voltage source intact. So we will keep this dependent voltage source intact and we will short circuit this voltage source. So on short circuiting this we get I is equals to 0. So when current I is equals to 0, then this current source will become equals to 0, because this is dependent on this current I. When this I is 0, this is also equals to 0. So when this is 0, then this acts as open circuit. So when this is open circuit, the RTH we get is simply equals to, suppose when this is open, in that case RTH is simply equals to R2. So here RTH is equals to R2. Now what is Norton current IN? Now again redraw this circuit. Norton current IN means the current through this terminal AB when we short this terminal AB. So when we short this terminal, then this current alpha I will flow in this loop due to this short circuited path. So we get IN simply equals to minus alpha I. Why minus alpha I? Because direction of Norton current is like this, and this current alpha I flow in this direction. Okay, that's why minus alpha I.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.